this chapter, we'll discuss an infant's tools for exploring the world, so their physical, perceptual, and motor development. Here's an overview of the chapter. We'll discuss physical development, moving and grasping, perception, and becoming self-aware. At birth, a baby isn't able to do a lot of things that we expect human beings to be able to do. It can't hold up its own head, which is huge in comparison with the rest of its body. It has some basic reflexes, some basic perceptual capacities. The baby can eat, can cry, can relieve itself, but it can't do much more than that. Over the next few months, though, wow. In the first 12 months, the baby learns to sit, to stand, to stoop, to climb, and maybe even walk. In the second year, we see that physical growth slows a bit, but the baby makes tremendous strides in learning and refining activities. For example, climbing behavior drastically increases during the terrible twos, and many babies start to do a lot of running around. So one of the basic things that a baby is born with are reflexes. The newborn is born with these unlearned responses that are triggered by specific stimuli. And certain reflexes have survival value. For example, babies, if you put like a finger or something in a newborn baby's mouth, they'll suck at it. And this obviously has a survival value, and that they know, okay, if there's a nipple in my mouth, I need to suck it in order to get milk and be fed. Other reflexes are developmental precursors to later voluntary motor behaviors. For example, when a baby is standing on their feet, if they're about to fall, they'll step, right? And so this is a precursor to walking. So reflexes reflect the health of a child's nervous system, which is why if you take your newborn or your baby or infant to the doctor, they'll test that child's reflexes. So how does development proceed? Development in infancy works from the top down and the inside out. So this is known as the cephalocaudal pattern. This is the sequence in which the earliest growth always occurs at the top, like the head, with physical growth and differentiation working their way from top to bottom, so head to shoulders to middle trunk on down. And we also see this pattern occurs within sections of the body, so think about just the head. Well, the top parts of the head, the brain and the eyes, are going to grow and develop faster than the lower parts, like the jaw and the teeth. We see that growth is very rapid in infancy than during any other period after birth. Infants actually double their weight by 3 months and triple their weight by 1 year. If you think about clothing sizes for infants, typically it starts with newborn and then 0 to 3 months, 3 to 6 months. Some clothing sizes go 6 to 9 months and then 9 to 12, but some at 6 months will go 6 to 12 months. And then we see 12 to 18 months. So now it's not a 3-month gap, but a 6-month gap. And then 18 to 24 months. And then you get 2T and then 3T. And then 4T, so now it's a 1-year gap. So you see that growth is very, very rapid in infancy, but then it does start to slow down a little bit. Another thing to keep in mind is that average is not the same as normal. So there's a wide spectrum of what we consider to be normal when it comes to development. So you might be a little bit below average, a little bit above average, but you're still within the range of normal. Okay, let's talk about the emerging nervous system. Early in development, the brain grows faster than any other organ of the body. At birth, the brain is close in size to an adult brain, and it develops really quickly throughout infancy and toddlerhood. So the brain has 100 to 200 billion neurons. Neurons are nerve cells that store and transmit information. Between the neurons are tiny gaps or synapses. And this is where fibers from different neurons come together, but they don't actually touch. So neurons send messages to one another by releasing chemicals called neurotransmitters, which go across the synapse. Once neurons are in place in development, they differentiate. They establish their unique functions by extending their fibers to form synaptic connections with neighboring cells. Neurons form connections in the brain, so stimulation from the surrounding environment is necessary for these connections to survive. A surprising aspect of brain growth is programmed cell death. This makes space for these connective structures. As synapses form, many surrounding neurons die, actually 20 to 80% depending on the brain region. Neurons that are stimulated by input from the surrounding environment continue to establish new synapses, while those that are seldom stimulated soon lose their synapses. This is a process called synaptic pruning. You can think about it as use it or lose it. The mature brain is a set of interconnected regions, each with a specific function. So these functions become specified through this synaptic pruning. Think about learning a second language. We've used this example before. It's easier to learn a second language when you're younger because you still have many of these connections. Once you get older, if you haven't been using those connections, you lose them, and so it becomes more difficult to learn a second language. Here is a really helpful diagram of these connections between different neurons. So you can see at birth, those connections are still forming, but by you're 6 years old, there's a lot of synaptic density in the brain. There are many connections being created, but obviously you can't use all of those different connections. So by the time you're 14, the ones that haven't been used have pruned away, use it or lose it, so they've been synaptically pruned away. So think about some of the benefits to this synaptic pruning process. What are the benefits of having more connections than you really need early in life? Well, the biggest benefit is neuroplasticity. Do you remember we talked about this idea of plasticity, that people can change? So here, this is one of the benefits. It makes learning easier. You've got this neuroplasticity. So we're going to talk more about that in a second. Here's just a diagram that kind of depicts this use it or lose it phenomenon of synaptic pruning. It's really important that you guys watch the video that I'm posting on synaptic pruning because that's going to help you understand this a lot better.